Geomagnetism. We have magnetic force, the attraction or repulsion that arises between electrically charged particles because of their motion. So, electrically charged particles. When these particles are in motion, when the electrically charged particles are in motion, because of their motion, we have magnetic force generation. Attraction, it is going to be either attraction or the repulsion arising between the electrically charged particles. The electrically charged particles are going to either attract or repel when they are in motion. Magnets are attracted to iron because due to the influence of their magnetic field upon the iron. In iron materials, magnetic field is having an influence. When exposed to the magnetic field, the atoms which are randomly present, they start aligning in the direction of the magnetic field. When they are randomly present, but they are aligned in the direction of the magnetic field with respect to the iron. We have the liquid outer core. The liquid outer core is iron material. So the movement of the electrically charged particles, it is going to create a magnetic field. The atoms begin to align their electrons with flow of magnetic field, which makes the iron is going to be magnetized as well. This in turn creates an attraction between two magnetized objects. Magnetic field is surrounding the electric current is called electromagnetism. We have electric current as well, right? Electric current. And then we also have the magnetic field. The magnetic field is surrounding the electric current is what we call it as the electromagnetism. Now what is Earth's magnetism? What is geomagnetism? The magnetic field is surrounding the earth. First we be having our earth's geographic north pole, but the magnet is like this. The magnet is having geographical north and geographical south. It moves from the north to the south. And the angle is 11.5 degrees. This is the angle, the north magnetic pole, and then we have the geographical north pole, which was due to the tilt of the earth. We be having the geographical north pole, and then we have magnetic pole, north magnetic pole. So this is like geographical north pole, north magnetic pole. 11.5 degrees. South magnetic pole, geographical north, and in the south pole. Why there is a magnetic field around the earth? Because in the outer core the iron is greater than the nickel. In the composition of the outer core, the iron, we say it is greater than the nickel. Iron is greater than the nickel. So the composition is called as the knife. Iron sometimes become ionic, that is charged particles, due to the collision. So when the iron is going to become ionized, that is, it is going to become a charged particle. When the iron is going to become a charged particle, this iron is going to charged particle, it starts to move because of the rotation of the earth. When earth is rotating, due to this rotation, the charged particles, due to collision, how does iron becomes a charged particle? This is due to collision, right? Due to collision, the iron is going to become a charged particle. Here in the outer core, we say the composition is iron is greater than the nickel. Iron sometimes become ionic, is the charged particles due to the collision. These iron charged particles starts to move because of the rotation of the earth. And the charged particles, when they are under the motion, is electric current. When surrounding any electric current, there is a magnetic field is generated. So this becomes an electromagnetic field. First there is a liquid iron. The iron, due to collision with other iron particles, it becomes charged. And there is also a motion because of the rotation. When electric field is rotating, when electric current is created, due to the motion we say that the electric current is created. When electric current is present, we be having the magnetic field around it. This leads to the electromagnetic field. There is a continuous convection, even the convection current cycles in the outer core. The heat is generated from the inner core is creating this continuous convection cycles in the outer core, right? We say that the heat which is generated from the inner core, the heat from the inner core is creating continuous convection cycles in the outer core, which is leading to the electromagnetic field. Geographical north is where the pole star is present. Pole star Polaris in the North Pole is present in the geographical north. Now we are seeing definitions. Magnetic field associated with the earth, geomagnetism, is nothing but the magnetic field which is associated with the earth. Has an outer rocky material, so the outer is going to be rocky material, below the rocky material is a liquid outer core. Rocky outer material is the mantle. Below the mantle, we have a liquid outer core. Lower mantle is rocky, right? Which surrounds the solid center. Solid center, liquid outer core, and then rocky mantle. RM. Rocky mantle, liquid outer core, and then solid inner core. It is considered that the motion of the charges, that is the ion in the liquid part of the Earth's core, creates magnetic field, which is creating the liquid ion is creating the magnetic field. How does the motion of the charges in the outer core? Why or how there is a motion of the charges? Because of the rotation of the Earth. Because Earth is rotating. The heat is rising from the Earth's core, which results in the generation of convection currents of the molten material in the outer core. We say that the heat being generated by the heat is generated from the Earth's inner central core. Earth's central core. So we'll be having the heat. The heat is which is generated in the Earth's central core. This is due to the primordial heat, or it is also due to the nuclear fusion reaction, radioactivity. This heat is creating the convection currents. So this heat is the one which creates the convection currents in the molten material of the outer layer. The motion of the ions in this molten material would produce an electric current through which the Earth's core that results in the magnetic field around the Earth. Now we saw what is the Earth's magnetic field. What is the old magnetic field is what we call it as the paleomagnetism. Right. Paleomagnetism, paleo means old. It is an effort to study the Earth's magnetic field in earlier days. Through rocks, we can understand the earlier magnetic field of the Earth. Right. What is paleomagnetism? Paleo means old. Through the rocks which are present, we can understand the Earth's magnetic field. Let us see how. The first thing is Earth is having the geographical North Pole, geographical South Pole, and here is the magnet, right? So the magnet is having the North Pole and then we have the South Pole. Magnetic North Pole and magnetic South Pole, 11.5 degrees is the difference. Now this is north and this is south. From north to south, the magnet changes its direction from north south. The magnet just reverses its magnetic field for thousands of years, right? The magnet is reversing its magnetic field. Now let us take a rock. When magnetic field is moving from north to south, it is giving a certain alignment of these rocks, right? Once these rocks are forming, when these rocks are out of the magma, they start solidifying. Once they are solidifying, they go under the influence of the magnetic field and they become aligned. When they are solidified, this alignment retains over there and they act as even magnets. These rocks are the ones which are acting like a magnets. So when it is the no, magnetic field is from north to south, it is changing its direction, right? So the magnetic field of the rocks are also changed. When the magnetic pole is reversed, the new rocks which are formed from the magma, they have certain alignment. Earth had various magnetic fields as well. It also had two magnetic bars at once. So there are different kinds of alignment of the materials in the rocks which contain iron, and they also act as a magnet. By studying these rocks, we can determine where and how was the magnetic field of the earth before the existence of the human. Now, this is what we call it as the paleomagnetism. Paleo means old and magnetism. Right, it is a effort to study the magnetic field in the earlier days through the rocks. This is through the rocks. We are studying the magnetic field in the earlier days. This is through the rocks. The historical study of the Earth's magnetism through its rocks. Historical study, the past study of the Earth's magnetic field through the rocks is what we call it as the paleomagnetism. We have the mid-oceanic ridges. The mid-oceanic ridges is where there are creation of new crust, and we have trenches where the old crust is being destroyed. So the Earth's rocks which are present in the ocean is not greater than 150 million years. Because of the cycle of C4 spreading, we have new crust is formed and the old crust is being subducted in the trenches continuously. So when there is a new crust formation in the mid oceanic ridges, magma is going to rise and accumulates on both the sides. We can say that the magma rises and it is accumulating continuously on both the sides and it pushes the magma. This is what we call it as the slab push, right? It pushes the magma. When the magma is in the liquid state, the minerals are free. So we have iron, manganese, titanium have magnetic property. That is, they get attracted to the magnetic field, aligned in the magnetic field. So we have the iron, even the titanium, and then manganese. They are having magnetic property, so they get aligned to the magnetic field. This is the free state, freely aligned in the liquid. But when the Earth's magnetic field is passing through, they get aligned and the magnetic minerals arranged with respect to the magnetic field of the Earth. After frozen, the magnetic minerals never change the magnetic alignment. Now these rocks and are analyzed. Through paleomagnetism and fossil magnetism, we understood that magnetic field of the earth keeps on changing. Movement of the charges, convection currents and the heat is not uniform always. Their direction also changes. The entire magnetic field is reversed. Now we have minerals which are present in the magma have magnetic property. Now, when the magma is the one which is going to crystallizes, the crystals of ferromagnetic minerals such as iron and the titanium acquire stable magnetism which becomes frozen as the magma cools down. This acquired magnetism is what we call it as a fossil magnetism. The magnet properties are preserved in the rocks, right? The magnetic properties are preserved in the rocks, as in case of fossils, though they are called as the fossil magnetism. So we have paleomagnetism and fossil magnetism. Such rocks will have ferromagnetic minerals aligned in the same direction as the geomagnetic field at the time of its consolidation. When paleomagnetic evidences for a given region were checked over a period of time, a gradual change in the direction can be detected. It shows that the position of magnetic poles has moved steadily over time. This movement is called as polar wandering. The poles, so we'll be having now this is the magnetic pole. Now this magnetic pole might have been changed. The poles are wandering with respect to time. That is what we call it as polar wandering. They are moving steadily with respect to time. So here we call the terms as fossil magnetism, polar wandering, and then we have magnetism, polar wandering, and then we have the paleomagnetism. During the study of the ocean surface, some rocks are pointed towards the north and some towards the south. It is inferred that the rocks didn't change the polarity, but it is the Earth's magnetic pole which reversed its polarity. We have the reversal of the polarity as well. The first one is paleomagnetism, second one is the fossil magnetism, third one is going to be the we had another term as well. It is called as polar wandering. The poles are moving steadily is what we have, the polar wandering. And the fourth one is polarity reversal. Polar wandering and polarity reversal from north to south and south to north. Such reversal of the magnetic field can be brought by the reversal of convection currents. The reversal, why does the magnetic field reverses? Why the magnetic field reverses? Such a reversal of a magnetic field, such a reversal is due to convection currents reversals. Convection currents is being reversed. The magnetic reversal are usually experienced 2 lakh to 3 lakh years. What are auroras? Auroras are nothing but the electrically charged particles from the solar winds. They interact with the Earth's magnetic field. Right, when the electrically charged particles, so we say them as the electrically charged. When the electrically charged particles, we have certain particles which are electrically charged, and these particles are present in the solar wind. When these particles are interacting with the Earth's magnetic field, when they are interacting with the Earth's magnetic field, there is a creation of auroras. Auroras near the polar regions. It produces a spectacular light. What is aurora? Auroras are spectacular light. Spectacular light. So we be having the north pole is what we have the aurora borealis, and the south pole is where we have aurora australis. Poles magnetic field are weaker, therefore interaction of the magnetic fields and aurora happens. Right, aurora australis and aurora borealis.